what happens due to boxing and unboxing. Boxing and unboxing decreases performance. You know why? Because you have to jump between the memory types. In this case, you don't have any option, but you have to say convert dot to int.
Good morning, good afternoon, good evening, namaste, salam walaikum, sasriyakal, vanakkam from whichever location you are watching this video. So what are we doing today? Today we are covering C# interview questions and answers with code demonstrations around 6 important topics: stack, heap, value type, reference type, boxing and unboxing. So basically what I have done here is, we have around 21 questions. I'm flashing on the screen all the 21 questions, and it's going to be a 1 hour of super duper awesome video. One thing which I can guarantee out here is that once you see this 1 hour of video, right, you go to any C# interview, and if you're asked questions around any one of these 6 important concepts, it's a 100% guarantee from me that you should be able to tackle the questions, right? So 21 questions we are trying to cover, 1 hour of video. And the speciality of this 6 important topics are they're very much interconnected. I mean to say, for example, if the interviewer is asking you question around stack and heap, a very natural question or a connected question will go on boxing, unboxing. If he's asking about boxing and unboxing, then he will ask you about value types and reference types. So all of this, 6 things are very much interconnected. So when one is asked, there is a high probability that the other question will be asked, right? So with all that thought process, let us get started with the first question.
Explain stack and heap. What exactly is a stack? What exactly is a heap? When any application runs, for example, you can see we have the C# application out here which is running, and you can see that the C# application, while it is running, it is actually having certain variables and objects. You can see that there is a variable here, an int variable, there is a boolean variable, there is an object, right? So these variables, they have to be stored into memory, right? So at least when the application is running, these variables have to be stored in certain kind of a memory. So stack and heaps are nothing but they are memories where application variables, object pointers, object references are stored, right? Clean. Now one more question which comes, and I understand that it's a very, very noober question, I will say. But must be here the interviewer is just trying to trick you, right? So where exactly is this stack and heap stored? Are they stored into hard disk? So where exactly it is stored, right? Both stack and heap are stored in RAM, random access memory, and not on a hard disk, right? The next obvious question is, what kind of data goes on stack, or what kind of variables goes on stack, and what kind of variables go on a heap? Now many developers, what they do here is, they answer very bluntly, saying that primitive data types are stored on stack and objects are stored on heap. Now this answer is definitely partially correct, and in interviews when you answer a partially correct answer, but obviously you will get cross questions, and those cross questions can lead to more cross questions, right? So let us try to answer this question more accurately. On stack, primitive data types are stored, or we can say value types are stored, right? So primitive data types means int, boolean, these are primitive data types. So those are stored on stack, plus object reference pointers are stored, right? Object reference are stored. So it means, in other words, you can see that this is a test, this obj is a test object, right? Now this obj object pointer is stored on stack, but the name and age, this obj data is stored on heap, right? So on heap, actual objects or reference types are stored. Now this is a very important thing. Depending on implementation, even primitive data types can be stored. Let me answer this question again. On stack, primitive data types are stored, plus object reference pointers are stored, right? While on heap, actual objects or reference types are stored, and depending on implementation, even primitive data types are stored. This last thing is very important, that even primitive data types can go on heap, and we'll come to that situation. We will talk about that situation after some time. So now let's try to see a demo, so that the answer, what we have just said, it gets more solidified. Remember, when you do a demo or you do a practical, it gives you a different level of confidence in the interview while you are cross-questioned, by the interviewer. So you can see over here, I have a very simple console application, and in this console application, I have defined three variables: integer, y, int, an object, which is of the type class, right? Class test. You can see that I have this class test out here, which has name and age. So I have created this object of class test, and we have a boolean variable as well with the name xbool. And what I've done is, I have divided this code into two parts. In the first part, I have just declared the variables. I mean, like, I've just said int, y, int, and test object. And then later on, from line number 13, I've started putting the value. So you can see here in line number 13, we are saying y int is equal to 100. And then in line number 14, 15, and 16, I have initialized the object, and later on I've initialized the x boolean equal to true. So basically now when this application is running, right, the first three variables, the three variables out here till line number 12 are not having any values, right? So let us try to understand, that how these values are allocated on a stack and a heap, right? So I'm going to go and right click and add this variable to an add watch window. So you can see here, when we add a variable to an add watch window, we see a value. You can see at this moment I did not initialize with a value, and it is an integer data type, so he has made the value as 0. Okay, but we are not interested really in the value. We are interested in the memory addresses. Remember, at this moment we want to understand stack and heap, so we are more interested in the variable memory addresses, right? So so now to see the variable memory address, we have to go and say and y int. So if you just say y int, you see the actual value, but when you say and y int, right, you see the memory address, right? So what we'll do is, let us go ahead first and let us put all the three variables memory addresses out here. So what I'll do is, let me start from bottom here. I'll say and xbool. So let us put each one of these variables out here. This is an object, so and object, right? And then finally we have and y int. So you can see here what I've done is, I have actually we now know the memory addresses of these variables out here, right? So you can see here the xbool is positioned somewhere in E404, the object is somewhere in E408, and the y int is somewhere in E414, right? So this is an hexadecimal value, which is actually saying that this xbool is located now in this hexadecimal memory address space on the RAM. This 7E408 hexadecimal value is saying that the object reference is stored into this location, right? So we are actually getting the location. Now let us try to understand this first. If we understand this, then stack and heap would be very clear, right? So what I'm going to do is, I'm going to go and take a print shot of this, and let me try to explain you what is happening out here. Now the first thing which I want your eyes to catch here is that the memory addresses of the variables, means of all these variables which are there in the method, are contiguous in nature, right? Means they are just one after another. There is no gap in between the memory addresses. So look at this. This is xbool here, right? So for xbool, you can see 0x00003485B7 E404. Look at the obj's address out here, 0x003485B7 E408. For now, leave this 0x00 for now leave that address. We'll come to that later on. Look at y int, 0x003485B7 E414. So you can see 404, 408, 414. So they are contiguous in nature. There is no gap in between. Means, it's not like, that xbool is lying somewhere here and then obj is lying somewhere here. No, they are one after another, and that's why it is a stack. stack memory. For now, leave the heap aside, leave the heap aside. Okay, so you can see here, we can say that, okay, down, we have E414, and here we have y int. After that, we have obj, right, which is located at E408. At this point, I'm not writing this big address here, 0034855B7, because that is all common, right? And then we have xbool, which is E404, right? So you can see that the way the variables are allocated, it is a stack. This is a stack. This is a stack memory. It is one above another. It is contiguous in nature. It is just side by side. There is no gap in between them, right? That's how the stack memory is. And stack follows LIFO, last in, first out. Means what? For example, you can see here, this is xbool, which is the last variable. It is now in the stack. And when the application finishes, at this point, the application will exit. And when the application exits, right, it will first remove this, then it will remove this, and then the first one which was inserted will be removed last. So it follows LIFO. Again, this is a very important thing, in interviews. He can ask, that how is the memory deallocated, right? So it is LIFO. Okay. So I'm trying to summarize, that what we are trying to say here. 2 points I want to say. First thing, the memory addresses are contiguous. Second, it is a stack memory and it goes with the LIFO style, last in, first out. So when the memory is cleared, when the application stops executing and it exits, right, the way the memory is cleared, it is from the top, right? Remember, it's a stack, right? So for example, if you have a stack of a book, right, or if you have stack of clothes, so what you will do, you will first, whichever is the last will be coming out first, and whichever is the first will come out last, right? So it follows the LIFO style. So remember that in the interview, in case the interviewer asks you that how does stack work, it is LIFO. So while releasing the memory out to the operating system, it will follow the LIFO style.
Now, before we go to the next question, right, I want to make an announcement to everyone out here. If you go and if you share this video on LinkedIn, on Facebook, on Twitter, or somewhere out there, right, I will give you this ebook. This ebook covers, some very, very important C# interview questions with answers, with code demonstrations. So basically, it will help you to clear at least the basic part of the interview, right? So if you go and if you share, what you can do is, once you share, right, just send us a mail at questpond@questpond.com, and we are more than happy to give you this ebook. Now, also, I would like to highlight here that down below in the comments, if you go to the comments down below, right, you will see that, I have highlighted a comment, and in that comment, we have like 1 hour of free video on C# interview questions, on SQL Server interview questions, on Angular interview questions, on MVC interview questions, and many more interview questions out there. I would suggest that you can take a benefit of that if you go and if you subscribe to our QuestPond's Teachable. If you subscribe to questpond.com, you would get all of these courses, as part of the subscription, right? So let us start with the next question.
One more important thing we should derive from this snapshot is how the values are stored. If you see here, for example, now, if you see y int, this is an integer data type. It is a primitive data type, right? Primitive means basic data types like integer, boolean, double, and so on, right? So those are primitive data types. Okay, so you can see here this y int is out here. This is the memory address, and you can see down below I've expanded this, right, and the value is stored right out here. So wherever the memory address is, the value is stored right away out here. Now let's look at another primitive data type. We have boolean. So you can see xbool is here. This is the memory address 404, right? And the value is stored right out here. At this moment, it is not initialized, so the value is false. Integer, if you are not initialized, the value is 0, right? But the value is stored wherever the memory address is. So the memory address points directly to the value, right, in case of primitive data type. Now let's look at this obj. If you see this obj is located at E408. At this moment, this obj is not instantiated. Remember, our debug point is right out here. We have still not executed this part of the code, right? This is still not executed. So the obj at this moment, you can think about it, is not pointing towards anything, right? So you will see here, this obj at this moment is not pointing towards the actual data. It is pointing towards a memory address, right? It is pointing towards a memory address. So one more thing which we need to derive from this is that in a stack, this is a stack, right? In a stack, the primitive data types, memory address points towards the value. But when you talk about objects, when you create an object, so in case of an object, it points towards another memory pointer, right? And that memory address will point towards the value. So you can see at this moment there is nothing. So that's why it is showing 0, 0, 0, 0, 0, because there is no value. At this moment, the object is null, or it is nothing, I will say. So here, once this code is executed, this will point towards that memory address and the value will be stored in that memory address, right? And that is nothing but the heap. So this is a stack and this is a heap. In stack, what goes? In stack, primitive data types go. Their values also go here. Primitive data types go, the values also go here. But when it comes to objects, a pointer is stored on the stack. There is a pointer which is stored on the stack and the actual data is then stored on the heap, right? So let us go ahead and execute this program and let us try to see that, how things changes. So there you can see we are debugging, right? So at this moment, nothing is initialized. Remember that when the application runs, right, the compiler already knows, the variables and so on, right? So you can see the variables are already allocated, their memory addresses are already allocated. Only thing is that, the values will go on later on, right? So now let us go here. You can see this is false, this is 0. At this moment, the obj is also not pointing towards anything. So let us go one step by one step. So when I say y int equal to 100, you can see the value is now here 100, right? If you go and if you move ahead, you can see now, look at this. This value is true. You can see now the obj is now pointing towards an actual address. Previously it was 000. Why? Because there was no object, but you can see now at this moment it is pointing towards another object, right? Let us take a print shot out from this, and let us try to understand a few things on this print shot, right? So let me go here and let us try to understand some more points on this print shot, because at this moment the values are instantiated, the values are assigned, the object is assigned, right? So certain things have changed in the snapshot. Let us try to understand it. Now let us focus on this image, because this image has the data. Now I'm going to again repeat everything about the stack, right? And also I will introduce, how the heap is working. Okay. So I know that I'm reiterating, I'm revising, but see, at the end of the day, we want to clear the interview, right? And especially around this stack and heap and boxing, unboxing and garbage collection, right? There are many small things here and there, and if you answer something wrong, or if you answer something which is partially correct, right, it will just lead to more questions, right? So let us spend some time, and one thing I can guarantee, right, this is Shiv Prasad Koirala's guarantee, that if you go through this video properly, 100%, nobody will catch your hand on stack and heap during the interviews, right? So let us iterate again. So here it is, this is a stack, right? And remember that we have 3 variables, and stack goes LIFO, last in first out. So there it is, the first thing is y int, right? So y int will go on the bottom out here, and because this is a primitive data type, so remember y int at this moment is stored in E814. So we'll just write it out there, E814, and the value is 100. So in case of primitive data type, the memory address directly points towards the value, right? So that is the value. After that, we have the object, right? Now remember that at this moment, the object has data, name is Shiv and value 100, and where it is located, E808. Remember, this is contiguous, right? So this is where the object is. Now you can see that this object is not pointing towards the actual data. It is pointing towards another memory address. Previously it was 00000. Why? Because our object was not instantiated, but now it is no more 000. It is 0000 1B68000ADC0, right? Which means that it is now pointing towards an address, and this address, is located somewhere, right? And that somewhere is nothing but the heap. Remember, this is a stack, this is a heap, right? So on the heap, this value Shiv and 100 is stored, right? And after that, we have our X bool. Again, it is a primitive data type. The value is stored wherever the address is. So this is true, and it is located at E804, right? So you can see that is the stack, right? That is the heap. Now, one very important point out here, if you look at the memory addresses of stack, you can see here E808, E814, E804. These are all contiguous. Look at the memory address of the heap. Somewhere it is, if you look at this memory address 0095 EC37, EC37, E808, EC. But look at this memory, it is somewhere different, 68,000 ADC0. So it is located somewhere on the heap, right? It is not a part of the stack. So that this memory address value here, it clearly says that it is not a part of the stack, right? So what goes on the stack? Now again, reiterating that answer, on stack, primitive data types go, right? The values of the primitive data types go on the stack, and also objects and the reference pointer. Object reference pointers, not the actual object data, those go on the stack, right? And on the heap, the actual object data, and also primitive data types can go. If you look at this age here, you can see this age is equal to 100. This age is not stored on the stack, it is stored out here. So in case if the primitive data type is a part of an object, then it will go on a heap, right? So that is the complete answer. What goes on a stack? I repeat this again, on a stack, primitive data types plus object reference pointers will go. What will go on a heap? Actual object data and also primitive data types in case it is a part of an instance. So one favorite question of the interviewer always comes is that, can primitive data types like integer and boolean can go on a heap? The answer is yes. If it is a part of an object instance like this, it can go on a heap. It will go on a heap, not can, it will go on a heap. If the same primitive data type is standalone like this, you can see here this int y int. If it is standalone like this, I'm sorry, my pen is blinking out here. What happened? Hang on. Okay. So if you see this int y int like this will actually go on a stack and not on a heap, right? So I think this answer, when you're answering, right, and it's a favorite of many interviewers. Can primitive data types go on a heap? Yes, depending on how it is implemented. Part of the object, it will go on the heap. If it is not part of the object, if it's inside this method or a function standalone, it will go on a stack. So what goes on stack, what goes on heap? Let us try to conclude a very good answer out here. So on stack, primitive values are stored plus object reference pointers. That means the object data is actually not stored on stack, the reference pointer is stored. And second, on heap, actual object data is stored plus primitive data types can also get stored depending on situation, like where the primitive data type is a part of an object. So that's the answer the interviewer is expecting. So try to give a holistic, end-to-end, a fully what you call truthful answer, so that you don't get into cross questions. Now, when you talk about stack and heap, right, you will definitely get, some questions on what are value types, what are reference types, or you can say what is byval and what is byref, what is, copy byval and what is copy byref, So all these words are all synonyms, So in other words, what are value types and what are reference types, right? So let us try to understand them.
One of the questions, which has come to my mind is, as I was going through these questions and answers and demonstration, that if a developer is not able to answer these questions, does not that make him a good developer? Should not we select him? Because I know many developers out there who very well execute projects. They don't understand stack and heap, they don't understand these boxing, unboxing, but they fantastically, they actually go and execute a project, they make it live, customers are happy. Now in this, there are two schools of thought. One school of thought says that we should ask questions around only what they are working on. For example, if he says I worked on SQL, ask on SQL. If he says I have worked on this, ask questions only around, things what he has worked on. But then there is another school of thought also who says that no, see, at the end of the day, if he does not understand stack and heap, if he does not understand the performance issues of boxing, unboxing, how can he create good applications, right? So there are two schools of thought out here. I want to know from everyone out here, what do you think? Do you think that these questions, they should be able to answer? These are fundamental questions, or you say no, it's okay if they are not able to answer, right? So let me know from which school of thought you are on the comments below. It will help me to also get more matured. But at the end of the day, interviewer is the king. And these questions are asked in the interview. You like it or you don't like it, right? So we are here to clear the interview. So let us move to the next question.
So let us first start with value types and reference type. Value types are primitive data types, while reference types are objects. I'll repeat this. Value types are primitive data types, while reference types are objects. Now you will say then, why are we saying reference type? Why are we saying value types? We can just say primitive, we can just say objects, right? It is because of the behavior, these variable exhibits, when you assign a value. So when you actually assign a value, for example, you can see in this line out here, we are trying to assign a primitive data type value to another primitive type, right? And look at this over here where we are trying to assign a reference to another reference type. So when this assignation happens, right, at that time there is a certain behavior which is exhibited, and because of that behavior it is termed as value types and reference type. So let us try to understand that behavior. In order to make you understand the behavior, what I have done out here is, you can see here, I have this code out here, and this code is completely executed, and I've created a snapshot, with all the variable addresses out here. So in this code, what we have is, we have two variables out here at the top. One is y_int, which I've assigned with the value 100. So this is a primitive data type. And then I have created an object which is of the type test, which has name and age. And then later on, in the later part of the code, what I'm doing is I'm assigning this y_int to z_int, and I'm assigning this obj over here to obj1, right? So let us try to understand that what happens out here. So first thing, you can see that this is a stack out here, and you can see all the memory addresses out here. So first thing, E794 is where we have our y_int, which is 100. Then we have the obj, which is E788, and this obj, as we said, it has a pointer here, ADC0, and the value shiv and 100 is allocated on the heap, right? Now what we are doing in this line out here, we are trying to assign y_int to z_int. Now look at this. When we do that, right, the z_int is having a new memory address, E784. So this is z_int, and in that z_int, we have the value 100, right? Now let us look at this statement out here. What happens when you allocate obj to obj1? So the obj1 is there again here on this E778 is obj1, and you will see here that this obj1 is pointing towards the same ADC0. You can see both the addresses of OBJ and OBJ1 are equal. So this is also pointing towards ADC0, means what? That this is actually pointing towards the same data out here. So yes, the object pointers have different memory address, but the inside pointer is pointing towards the same data. So what is the big difference out here? When we actually assign the value types, a fresh copy of the variable was created, a fresh memory address was created. So this E794 value was copied to E784, which is a different address, and it was allocated completely different, decoupled. So if I go and change this to 200, this is not going to go and change E794. So that's why it is termed as value types, or a lot of people also say this is copy by value. Why? Because you are copying by value. It has fresh memory address. It has no connection with the previous address. Now look at, this when OBJ was allocated to OBJ1. In this case, if you see, yes, there is a new memory address for the pointer, but both the pointers, it is just copying the reference. He just copied the memory address out here. This ADC0 was copied over here, not the actual data. He did not make a copy out here, guys. This did not happen. So this is called as copy by ref, right? Copy by value, copy by reference. So the interviewer can ask you questions in different ways. He can say, okay, what are value types and reference types? So value types are nothing but primitive types, wherein the values are copied and a fresh memory address is created. While in case of references, when you actually move the objects, reference are copied, they point towards the same data. If you go and if you change this shift to Shiva, it will change for OBJ also, it will change for OBJ1 also. For both of them, this data will change because both of them are pointing towards the same memory address. So the interviewer can ask you in various ways out here. He can say, explain, copy by val versus copy by ref, or he can say value type versus reference types, or he can say, what do you mean by byval and byref? If you get any one of these questions, he is expecting the answer that one is copied by value and another one is copied by the memory address, that is the reference. So if you are asked a question on stack and heaps, if you are asked a question on value types and reference types, very but obvious, or I will say there is a high probability that you will be asked a question on boxing and unboxing, right? So what is boxing and unboxing? Boxing and unboxing is nothing but it is a process which happens when your variable jumps from a stack to a heap and from a heap to a stack. So when the variable jumps from a stack to a heap, it is termed as boxing. And when the variable jumps from a heap to a stack, it is called as unboxing. Remember in the interview, when you're asked a question that what is boxing? And if you don't remember, like, is it from a stack to a heap or from a heap to a stack, right? You can just remember like this, saying that, okay, I will box things up and throw it in a heap. And I repeat this, you will box something up, like you will box your clothes, you will box your books, and you will just throw it, in a heap, right? So boxing is nothing but, moving from, when your variables actually move from a stack to a heap, right? And unboxing is when your variables moves from heap to a stack, okay? So let us try to understand, what happens in boxing and unboxing, via the code and via the memory addresses. So you can see that we have a very simple code here. It is just a 3-line code. So in this first line, we are assigning int I equal to 100. Now remember that this is a value type. And in the second line, we are trying to move this value type to a reference type, right? So this is where boxing will happen, right? And then you can see in the third line out here, I'm trying to move this object to an integer. So I'm using this convert function. So this is where unboxing happens, right? And let us see what happens out here, right? So let's draw our memory addresses. We have a stack, we have a heap, right? So First thing, we will see here int I 100 E794. So where we have int I equal to 100, right? Okay. After that, this int I is moved to an object, right? Now what happens out here? You can see the reference pointers object out here is E788. It is out here. So this is obj, and he's pointing towards this another memory address. Remember, this is byref, so it points towards ADA0, and that ADA0 now has value 100. So what has happened out here is, when you actually try to move this int I to object, right, it actually copied this value into the heap, right? So this is where we are seeing boxing has happened, because it has copied the value and then assigned the variable. Now look at the third line. So if you look at the third line, int z is E784, right? And int z, it is now 100, right? Now in this case, what happened? This object value is, data is now converted into integer and a copy is made. This is unboxing, right? So you can see that very clearly, when you're moving this data type values actually from a heap to a stack and a stack to a heap, an actual copy happens. It actually copies, it actually creates a new memory, it actually allocates value and so on. So it's quite a resource intensive process. So one of the next question which the interviewer can ask you is that, so is boxing and unboxing good? No, definitely. As a developer, we should try to avoid boxing and unboxing as far as possible. If you remember our first video, our first C# interview question video, where I had shown a simple demo that how boxing and unboxing can lead to a lot of boxing and unboxing can lead to a lot of issues with the performance, right? And we'll see a demo also. Let me see that if I can get a chance to show you the demo as well, right? So definitely moving values, from one memory type to another memory type. Remember, this is a complete different memory type heap, and this is a complete different memory type stack. So when you're moving a value between heap and a stack and a stack and a heap, definitely your performance will decrease, right? So you should try to avoid it as far as possible, but the reality is that it is unavoidable. There are many situations, wherein it is unavoidable. So one of the things, which the interviewer wants to hear is that we should avoid it. For example, in this case out here, this is really, really a bad practice. I mean, there is no point of moving this integer into an object. There is no point of moving an object to an integer, right? So such kind of things should be avoided. But then, there are some situations like this, for example, look at this. Let us say that you are taking an input. So now let us say you're taking an input out here. Let us say you're taking an age input, right? So you'll write here console.readline. Now, if you see out here, this console.readline out here, it is a string. You can see this is a string. And remember, strings are objects. We'll come to that later on. After this, the next question is that are string primitive data types or objects? We'll talk about it. Now, this is a string. It's an object. And what you do is you are taking the input from the keyboard, right? So in this case, you don't have any option, but you have to say convert dot to int, right? So when you're taking an input from a text box, from a combo box, from a UI into a variable, or must be you are trying to bind your variable to a grid, right? In such cases, boxing and unboxing is unavoidable, right? But unnecessarily, doing like this, does not make sense. Let me show a small code out here that how boxing and unboxing, actually affects performance, right? So what I will do is, let me go here and write a simple code. So let me write a static void check performance. Okay, let's write a simple thing out here. And what we'll do is, first we will, so this check performance, what we'll do is we will run it. Let us do like this. Let us run this code, this block of code, for 1,000 times. Let us try to check performance. Okay, so we'll just run it like 1,000 times, or must be much more than that. I'm running it, right? So we are trying to run this code in a big loop out here, right? And what we'll do is that we will use the stopwatch, right? So we'll use the stopwatch to check the performance. Stopwatch is a nice class given out here in C#, which helps you to, it's a class which is in system.diagnostics. It helps you to accurately measure time. It actually, when you're talking about performance, if you want to measure something, then this is the watch, because it gives you an accurate time. If you're using the date and time clock, then there are a little bit of inaccuracies out there, but here this is like quite accurate, right? So I use it, sometimes to measure performance. So I'll just say new stopwatch out here, right? And I will say start the stopwatch, right? And we will run this check performance, and we will stop the stopwatch, right? Great. So and what we will do is remember that in .NET what happens is the IL code gets converted into machine code. So first thing, when you compile, it is an IL code, and then later on the IL code gets converted into a machine code. So what I'll do is I'll just run this check performance multiple times first, just to make sure that our IL code is converted into machine code, and we are not measuring the time of conversion of IL code to machine code, right? And I will just do a console.read out here, and I will also do a console.write line saying that, tell me what is the elapsed ticks of the stopwatch, right? So at this moment, what I'm doing is I'm trying to move. We are actually doing boxing unboxing. So basically, we are actually we are actually doing boxing. So we are actually moving unnecessarily a primitive type to an object, right? So let us see what happens here. So I'm going to go and run this, right? So there it is running, and let us see. It will take a little bit of time. See, remember, whenever you read something, when someone says that, okay, boxing and unboxing decreases performance, you should write, such kind of small code and solidify your thought process or solidify your knowledge. Or else what happens, like you just read it, but, until you don't see it, until you don't do some demo, right, it does not get registered into your head. It is taking a bit time, must be because... Oh, it had already ran at the back. So there it is, 4609. I'll just run it multiple times just to make sure it's the same thing. 4633, 4609, 4633, 7645. Suddenly it is 7645. 5625. Whenever you are measuring performance, right, just make sure that it is consistent. It is not like sometimes it is 4 and sometimes it is 40,000, right? So I'm just running this multiple times, to just check. So 7045, and then 6355, and 4800. So 4,000 to 7,000 is the range. I'll just put it down out here in the notepad that with boxing and unboxing, our range, was 4,000 to 7,000, right? That was the range. Now what we'll do is we'll go and we'll remove boxing unboxing. So I will just make this as int z. Okay, so there is no boxing unboxing now. We are just moving from a value type to a value type, right? Now let us measure the performance. Let us see. You can see now 1996. Look at it. It's almost 4 times lower, even if I take the middle range out there. You saw that as soon as that boxing unboxing was involved, right? Suddenly, because you have to allocate it on a stack, you have to find something on a stack. That's why we had this huge range out here of 4,000 to 7,000. But look at this. Look at when you're moving within the stack, right? It is almost consistent in that 1,000 range. So it's the difference is hardly 100 or 200, so you can see almost it is 1,500, almost every time when I run it is almost 1,500, and it never 15. So you can say 1,000 to 2,000, right? If I try to conclude this, it is almost 1,000 to 2,000, almost. Okay. So if you look at this difference, so look at this. This is the difference, when you had boxing, and this is the difference, when when you do not have boxing. So you can see that how the performance is impacted. So remember, whenever the interviewer asks you that what happens due to boxing and unboxing, boxing and unboxing decreases performance. Why? Because you have to jump between the memory types. Second, is boxing and unboxing avoidable? There are certain situations, where you take data from the UI, or must be your primitive data types you are binding to the grid. It is completely unavoidable because you have to do it, isn't it? But unnecessarily doing boxing and unboxing, those kind of code, should be removed, right? So remember this, that boxing and unboxing decreases performance, right? And it should be avoided as a best practice. One more question, it's a tricky question, which the interviewer can ask you, is that are string objects or value types? Are strings allocated on a stack, or are strings allocated on a heap, right? So if you see here, this is string X and I'm putting a value shiv, and if you see the memory address structure of X, you will see that it is a reference type. Look at this. This is X here, which is this 760 is the memory address of the pointer, and the actual value shiv is stored into heap in this address 628. So you can see this is actually a reference type. So strings are objects, they are reference types, they are allocated on a heap, please understand. And whenever you try to move like this, a value type, to a string, remember, it is doing boxing and unboxing. So if you're trying to move a primitive data type to a string or vice versa, that means that you are actually doing boxing and unboxing. So, from this image, it is very clear that strings are objects, strings are reference types, strings are allocated on a heap. There is one more tricky question, which comes around stacks and heaps, while C# interviews, is that how many stacks are created and how many heaps are created. So let us try to understand this. One stack is created per thread. I repeat this sentence. One stack is created per thread, and there is only one heap created. At least to my best knowledge, there is only one heap created. Yes, there are extraordinary situations where, multiple heaps can be created, but it is a very extraordinary situation, and I don't want to discuss that situation now. But one heap is allocated to an application, and stack is created per thread. So you can see here now, for example, this is static void main. So the application, this static void main will run in one thread. So int I and y will be put on a stack, put on stack 1, you can say. And you can see I'm creating one more thread here, and I'm running function 1 in that thread, right? In case you are new to threading, please see our threading videos which are there. So you can see here I've created a thread and I'm running function 1 in this thread. Now for X and Y1, a separate stack will be created. So if I run this, so you can see here, and int I, right? And let us say and Y. Okay, this is one. Now let us try to go inside the thread, right? So let us try to go inside the thread out there. So t.start, right? And let us try to also get the memory addresses of and X, and let us try to get the memory addresses of and Y1. If you see here, I'll just take a print shot and let us try to see what is happening, right? So I'm going to go and take a print shot, and let us zoom here and let us try to see what is happening. You can see here very clearly, for this static void main, one thread is created. So for that, there is a stack created, and you can see here the Y, right? The int I and Y are allocated on one stack. And how do you know it is on one stack? Look at these numbers out here. They are contiguous, So E718, sorry, it is up E718 and E724, right? Contiguous. Now look at the down numbers, which is because for here I have created a new thread, right? So this is running on a different thread. these numbers are not contiguous like the top. So that is a different stack actually. So over here now you can see the numbers are, for Y1 it is 4E8, right? And then you have 4F4, right? So this is a different stack and this is a different stack. So this is the stack, which is allocated to the main thread, right? And this is the stack, which is allocated to this thread T, which we have created, right? And definitely, there is only one heap created. So if there are any object reference pointers, we do have this Y, etc., which is there referencing the objects, but they are then created on the heap. So there is one heap, and per thread, one stack is created. One of the things, which an interviewer would like to test is that, do you know how the memory deallocation takes place? See, when any application runs and once the application exits, one of the most important thing is that whatever memory it is consuming, it has to give it back to the operating system. If it is not giving back that memory to the operating system, it leads to memory leak. And memory leak is not a good idea. Just think about it. You have an application which is running, you have exited it, and still it is holding some memory, right? So that would be a bad situation. So whatever memory is allocated, either it is on a stack or either it is on a heap, it should be given back gracefully to the operating system. So one of the questions, which the interviewer can ask you is that, how is the stack and the heap memory deallocated, or how is this memory given back to the operating system? So let us try to understand it. So here is a simple code out here. So let us try to understand by using this code that how the memory is allocated and deallocated. So let me first draw the diagram for stack and heap. I do understand that I'm drawing this diagram many times. I'm reiterating it many times, but believe me that, when you reiterate something many times, it just gets registered in your head, right? So we have int I. So down below in the stack, somewhere int I will be created with the value 10, and then we have int Z, right? So int Z is created here with the value 100, and then we have the Y object, and because it is an object, here there will be a reference pointer, and that reference pointer will point something on the heap, and on the heap we will have shiv and 10, right, which is there, right? So the scope of this whole thing is from here to here. So whenever this thread exits, so when this thread exits from this point, right, we want that all the memory, whatever is allocated here on the stack and on the heap should be given back to the operating system. That is the most important thing which should happen, right? So after this point, what happens now? After this point, first thing, it is very easy to deallocate a stack, because the stack, as we said, is contiguous in nature, right? So what happens is, as soon as this point gets executed, right, after this, or it goes out of scope, these variables go out of scope, right? This complete thing out here gets, this whatever is the memory out here is poured like a bucket, it's a stack, it's poured like a bucket, and it is given back to the operating system. So we don't have to worry about this. This happens immediately. After this point is executed. But then what about the heap? The heap memory is still out there, right? Now the heap memory, remember, is not contiguous. You can have some memory here, you can have some memory here, you can have some memory here, right? And so how does this, who goes and deallocates this? Because here it is very tough, that sometimes, something is empty, sometimes, something, it is not contiguous. In other words, the memory allocation is not contiguous out here, right? See, whenever something is contiguous, right, it is very easy to deallocate, very easy to carry a stack. Think about a stack of a book. It is very easy to carry from one place to another place. A stack of clothes is very easy to carry from one place to another place. It's because it is just one thing, right? But here in a heap, something is getting allocated here, something is getting deallocated here. It's difficult to know what to do, right? So the first thing is, who deallocates this? So we have our friend out here called as the garbage collector. The garbage collector comes undeterministically. Undeterministically means we don't know when it will come, right? But it comes undeterministically, and it says that, okay, which memory do not have once this whole thing goes off right from here, the stack is deallocated from here, right? There is no reference of these values now. There is no one referring here on the stack. So the garbage collector comes and says, okay, which are those memory addresses, or which are those memory places, which do not have any reference on the stack. So this does not have it on a stack. So the garbage collector comes and then gives back this to the operating system, right? So garbage collector goes and garbage collector is the person who actually, or the garbage collector is the process. I'm sorry, I'm saying it's a person, just a habit. So garbage collector is a process which runs in a background. It comes undeterministically and goes and cleans any kind of objects on the heap, right? While stack deallocation happens by itself. So remember that in interview, if one of the things which the interviewer is expecting from you is that you should know how the deallocation take place. So stack memory are easy to deallocate, easy to allocate, while heap memories it is easy to allocate, but it is tough to deallocate, and the heap memory gets cleared by the garbage collector. Heap memory gets cleared by the garbage collector. Stack memory gets cleared automatically because we know how the memory address scheme is. It is contiguous and so on, right? So this is what you have to communicate in the interview. Now there are three more questions which can come in when you talk about stack, heap, value type, reference type, and all these three questions are mostly revolving around structures. Question number 1. When you create an instance of a structure, right, or when you actually initialize a structure, are they allocated on a stack or are they allocated on a heap? Second, when you assign one structure to another structure, does it exhibit a byval scenario or does it exhibit a byref scenario? So does it does it copy the values, right, and creates a new memory address, or does it do a reference copy? And the last one is it possible that structures can also get allocated on a heap, right? So that's one more question, right? So you can see here, I will not answer these three questions. This image, what you see out here, already represents the answer, right? So you can see here what I've done is I have created a structure here called as my struct. I have created an instance of the structure S1. So you can see out here, this is S1. This is the memory address of S1, right? And you can see the values. So this actually answers the question number 1. I will not answer the question. All the three answers, I want, the viewers, our subscribers, to please put down in the comments the answers of all the three questions. Already my screen is already answering it. I will just, show the code and explain you. But if you can take all these three questions and answer them on the comment, that means that you have understood my lessons, right? So here it is. You can see this is S1. S1, this is the memory address, and these are the values. So that answers question number 1. Are structures allocated on a stack or are structures allocated on a heap? Now look at this, we are assigning this S1 to S2, right? So here it is, this is S2. You can see S2's memory address out here, and you can see the S1's memory address. This answers the second question, that whether structures exhibit a byval scenario or a byref scenario. So do they do a copy by value or copy by reference, right? So by looking at this memory address, by looking at these values, you can easily understand that this line out here, is it doing a copy by val or copy by ref? The last question, where I asked you that are there scenarios, wherein the structures can get allocated on a heap. So you can see here, I have created a test class out here. I have created an instance S3, and inside this I have created a structure. So you can see there is S3 out here, and you can see this thing, right, which answers our third question, right? So this answers question number 1, this answers question number 2, and this memory address out here answers question number 3. So I want that if you can go and put down in the comments, by looking at the screen, you can pause, you can go ahead and you can hit the pause button, and you can just watch this image, and if you can conclude what the answer is, and if you can write down below, that will really, I will feel that yes, people have understood, what I have been speaking for the last 1 hour.
Okay, so we have covered like 1 hour of video. Now, as a teacher, as a trainer, I want to know that how many people are watching me till here? Am I just alone speaking and nobody is watching me? It's YouTube, right? It's a C. So in case if you're watching me till here, if you're seeing this video, if you're seeing this bottle out here, right? If you can just go and tell me on facebook.com/questpond saying that yes, we did watch you till 1 hour, we liked your video, or if there is any constructive feedback, I'm more than happy to implement the same, right? Why I'm saying this, so it will help me to know that yes, people are watching me till 1 hour, I should record such kind of videos. It will motivate me, it will help me to, create better videos. So please do the needful. Okay. So that brings us to the end of this video. I hope you have liked it. Now what we'll do is, we have covered 21 questions, right? Let us go and do a quick revision, right? Because till now you were seeing the practicals, you were seeing the demos, right? But at the end of the day, if you don't revise, right, you will forget it. So this video is now going to end, but a quick revision will be done. And please note, as we said, if you go and if you share this video on Facebook, if you share this video on LinkedIn, if you share this video on Twitter, right, in any one of these social media channels, you will get this ebook, which I'm flashing right on the screen for free. So happy learning, happy job hunting. Let us start the revision.